Welcome back, folks, and good evening. We're now going through the density lab, and this is pretty much the write-up that the kids would have received from WhatsApp or email if they don't have a working phone. Either which way is fine by me. And so right now you're probably viewing video, and video shows the enthusiasm of the kids. They were very happy to do this lab. This is my third farm, my current third farm, 2019, and they will be showing you how they took the mass of the rock using a top pan balance. First they would tear or make it zero, and then they'll put the rock or the pebble on top, and they will record the mass. And then from there they would obtain some volume of water, and I told them to start from 50. I told them find a rock that could fit in the hole or the opening of the measuring cylinder, and then from there we could move on. And 50 sounds good, and so they would slide the rock into, they would first record the initial volume as 50, and then when they put the rock in there, the rock would take up a certain amount of space, right? And that space would be the volume of the rock, and this is called determining density via displacement of water, because the rock is irregularly shaped. Now, one of my students came to me earlier before this whole lab and told me, "Oh, teacher, I don't understand. I do not understand density." And rest assured, after she did the lab, she had no more problems, and that is how great practical work is. You're not able to see sometimes with theoretical stuff, like when the teacher is talking, you just can't see it. So when she did the practical work, she was able to now put the words to action, and I'm happy that she was able to do that. And because of her, I went on and designed this lab so that you would have 3 trails. And yes, I know if the rock gets wet, it would alter the mass somewhat. However, that can be dealt with in terms of we can dry the rock, we could wipe it with bounty paper, and that's pretty much the simplest way to do it. But me putting in these trails was so that the children could get accustomed to calculating density and to calculating relative density, and knowing that relative density doesn't have units, right? So doing trails also help the children. And even though I know that it would have been off a little bit, their calculations, just because of the wetting of the rock and all of that, it's accounted for in the overall process of things. Overall, I am happy that the kids, the students, are able to calculate density and relative density and have a little understanding, because they had to go and do a reflection. I don't miss reflection at all. I want them to go and look up something that relates to the topic. Now, this is the lab write-up. Now I have totally taken out me doing the lab write-up because it takes too much time, and I know 21st century kids, they just want to get to the point. I want to get to the point, so let's just get to the point. So here is the lab write-up, and pretty much you don't want to forget to put your name and the date, so don't forget that. Then you have your SBA number, the topic title, the aim. So the aim is to determine the density of the pebble. Then you have your equations here for you, the apparatus, the method. Don't forget, you have to convert the present tense of the method into the past tense. And here I have it, so you can put the video on pause to read it. Now, when you're writing past tense, it cannot be mass in grams of pebble determined using. No, it has to flow. It has to sound like a proper sentence. So don't forget your articles like the and So the mass in grams of a pebble was determined using a top pan balance. A measuring cylinder was filled with approximately 50 ml of water, and this was recorded in the initial volume as the initial volume of water, and we have VI here. Alright, so that's pretty much how it goes, past tense. And then we have the observations, which is quite obvious, when the stone was added to the known volume of water in the measuring cylinder, it rose. And then this is how your diagram should look. Okay, your diagram should look something like this, 2D. If you're writing in all common letters, then continue that. Try not to mix capital and common letters. And so this should be your diagram, close to it. Okay, and you see this is the drawn version of what you saw earlier. Moving on, we include our calculations, because this lab had a bunch of calculations, and I usually give the kids the formulas, because some children might know how to do it, some might not, and it also cuts my work in half, because sometimes you leave it blank and then the children do all sorts of things and then they don't understand what you're looking for, so you have to lay it out for them. And with this practice, could you imagine how much better they will be able to tackle their tests, right? So I write down the calculations that I'm looking for, and if they have anything to add, they could most certainly add it. You know, sometimes they debug some of my labs, and I'm pretty happy about that. So for this, I wanted them to learn how to calculate average mass of a pebble, which is where you add up all the numbers in the area, and how many numbers you have, you divide it by that, and you put your average number here. Then I wanted them to figure out the volume of the pebble, which they did 3 different times. And so at the end of this lab, they're supposed to know that to find the volume, you minus the initial volume you had from the final volume. So you see what I did there. Then they find average again. So all of them are learning in this some type of math. And so they know that math is interwoven with physics, which is great. And so they do all this math. And if you want, you could pause it and see what I'm talking about. And again, the kids were very happy about this, even though it was a little bit time consuming. They were pleased. Okay, now I forgot to, so this is how it looks, the final product. And then we went on to discussion. It says here, the density of a substance depends on what it is made of and its mass. Density can be determined by dividing mass in grams by volume in centimeters cubed. Or you could have in kilograms divided by meters cubed, but because we use very small units in the lab, we use grams per centimeter cubed. The denser an object is, the heavier it is. If an object is placed within a fluid and it flows, then it is less dense than the fluid. If an object sinks within a fluid, then it is more dense than the fluid. The pebble sank in the water because it had an experimentally determined density of 2.85 grams per centimeter cubed, which is greater than the actual value of density for water, which is 1 gram per centimeter cubed. So when you're writing up your discussions, you need to incorporate the experimentally determined values that you determined. You must incorporate some of your results and the major results. Don't say the average value for the You don't need all that, because you're really dealing with the density. We could see that in the results, but focus on the density when you're comparing your stuff. Focus on things that you need to compare. Stick to the aim. You don't need to go all around the bush. Stick to the aim, and then your discussions will be short and neat. Okay? Alright, a limitation would be incorrectly calibrated volumetric instruments could lead to inaccurate results. Precautions: volumes of water were read below the meniscus. All glassware was handled with care. Reflections: I have a greater understanding for why I am more buoyant in seawater than in pool water. Seawater is more dense than pool water because it contains many types of salts, whereas the contents of pool water does not. Hence, one should note that learning to swim in a pool will take more practice than if one learned in seawater. Great. In conclusion, the density of a pebble may be determined via the displacement of water. Always tie back your conclusion to the aim. And this took me approximately 30 minutes to complete. So, you know, with time, you'll be able to do your labs much quicker than the first time you ever started a lab. Now, folks, good night and good luck. And I hope you take something with you from this little video. Alright, bye.